Hello, Bacho. Let's read the question. The question says here, if the short wavelength limit of the continuous spectrum coming out of a Coolidge tube is 10 Armstrong, then the de Broglie wavelength of the electrons reaching the target metal in the Coolidge tube is approximately what? Let's find out. So, the maximum allowed energy of particles coming out of the Coolidge tube is fixed. The electron energy is converted into X-rays. Okay, as a result, you can apply the energy conservation theorem to find the momentum of the electron. You can use the de Broglie hypothesis to find the wavelength of the electrons. Okay, so the de Broglie wavelength is given by lambda de Broglie is equals to h by p. This is equation 1. So the kinetic energy of a particle is given by kinetic energy is equals to p square by 2m, equation 2. Okay, so the energy of a photon is given by E is equals to hc by lambda. This is equation 3. Okay, so where lambda de Broglie is the wavelength of the particle, lambda is the wavelength of the photon, h is the Planck's constant, c is the speed of light, p is the momentum of the particles, m is the mass of the particle. Okay, so the short wavelength limit of the continuous spectrum is given by, hence the energy of the photon energy is hc by lambda minimum. It should be equal to the kinetic energy of the electrons. Okay, so the kinetic energy is equals to p square by 2m here. Hence we can write hc by lambda minimum is equals to p square by 2m. It can be written as p is equals to root over of 2m hc divided by lambda minimum. Okay, so the momentum of the electron is p is equals to root over of 2m hc by divided by lambda minimum. So now we can find the de Broglie wavelength using the equation 1, this one. Okay, so lambda de Broglie is equals to h into 1 by root over of 2m hc divided by lambda minimum. So it will be root over of h into lambda minimum divided by 2mc. We know we know the following: c is equals to 3 into c is 3 into 10 to the power 8 meter per second. H is 6.626 into 10 to the power minus 34 joules second. Lambda minimum is 10 Armstrong, which is given here. Okay, so m is equals to 9.19 into 10 to the power minus 31 kg. Okay, hence the de Broglie wavelength is, we'll put the values, root over of 6.626 into 10 to the power minus 34 into 10 into 10 to the power minus 10 divided by 2 into 9.19 into 10 to the power minus 31 into 3 into 10 to the power 8. Okay, so it will be 0.3 Armstrong. Okay, so the de Broglie wavelength of the electrons reaching the target metal in the Coolidge tube is approximately 0.3 Armstrong. Option A is the correct answer. Thank you.